the three man's work. So let's get on with it. So today we'll be teaching about instruction pipelining. So what is instruction pipelining and how does it improve the CPU's throughput? Instruction pipelining is a technique for implementing instruction level parallelism within a single processor. So you students, you may question, what is instruction level parallelism? What does it mean? It just means that it's a measure of how many instruction sets can be run simultaneously within a computer program. Okay, so class, today, what is the definition of instruction pipelining? Instruction pipelining is a technique for implementing instruction level parallelism within a single.
You understand the part about the 5-step pipelines?
Yeah, what's wrong?
Can you explain it to me?
Sure, just look at the board.
So Gavin, firstly, fetch is a process which is carried out by the instruction unit where instructions are fetched from memory and executed in an appropriate order. Secondly, decode is a process which is carried out by the instruction decoder, which is a circuitry that converts the instructions fetched from the memory into signals that control other parts of the CPU. Lastly, execute is a process which is carried out by the arithmetic logic unit or ALU and other internal units that perform the computations and operations as instructed by the computer program. This figure in the next slide is about the partitions of the MIPS single cycle data path, whose CPU is the RISC computer. As you can see, each part of the instruction is carried out by different parts of the CPU. So as the steps are carried out by different parts of the CPU, they can be carried out at the same time, hence ensuring efficiency. Hence, the 5-step instruction pipelines can be overlapped. Now do you understand, Gavin?
Yeah, I understand.
How does instruction pipelining work? Gavin, can you help me out with this?
Sure, you want me to explain it to you?
Yeah.
Alright, let's see.
Okay, thank you.
Alright, any cats? You want me to explain about how instruction pipelining works, right? So let us look at the washing machine analogy. So imagine that there are two types of machine. One is washing machine that only wash one shirt at a time for 30 minutes. And dry machine dry one shirt at a time for 40 minutes. And each machine has the maximum capacity of washing and drying one shirt only. So if I were to say to wash one shirt for 30 minutes and wait until it's finished, then I go and dry the one shirt for 40 minutes and wait until it's finished. Then I repeat it to wash and dry 3 shirts. Is this the most efficient way, any cat?
Maybe?
Sadly, the answer is no. Actually, what you can do to improve the efficiency is while you are drying the first shirt, immediately you go and wash the second shirt in the washing machine. So by the time you finish drying the second shirt, the first shirt, you have finished washing the second shirt.
So Gavin, what's the difference between a CPU with pipelining and a CPU without pipelining?
Alright, so let's look at the slide again. In this figure above, you see that for the instruction 1, it executes the 5-step pipelines, and until it finishes, then the second instruction continues to execute. If this was the case, the total unit of time to execute both instructions is 10 units of time. And with instruction pipelining, after the first instruction finish the instruction fetch and go to instruction decodes, the second instruction can execute the instruction fetch at the same time. So if this is the case, the total time taken for those two instructions is now 6 units of time. It shortens the time and thus increase the CPU throughput. Yeah.
Alright.
Attention to me again. So I'll be talking about the disadvantage of not using pipelining for every CPU. So first reason is that it's harder to implement in CISC computer, which means complex instruction set computer. So for example, Intel 32-bit x86 IA32 architecture has a size of instruction range from 1 to 12 bytes, which means that the computer will only know instruction fetch is done when you only start with instruction decode. Instruction can take one or more cycles to be fetched from memory. Why is that so? So for example, your instruction set
is 12 bytes, and then it has to retrieve from memory, and it retrieves 4 byte by 4 byte by 4 byte. Hence, it takes more than one cycle. And then thus, CISC computer complicates the pipeline process, whereas all ARM instructions, one of RISC architecture, which is reduced instruction set computer, has exactly 4 bytes, making pipelining predictable. So the second disadvantage will be branch delay. While the current instruction is in execution, the following instruction will be in the pipeline already. So for the next statement, I'll give you a real life context to explain this. So for example, you're queuing for chicken rice stall. Then you're in front of the vendor, and the vendor is asking you, what do you want? And you're still there thinking if you want to eat chicken rice or char siu rice. This will be your conditional branch. And the CPU, which you know the next instruction will be the boss, and then the next instruction will be the next customer in line after you. And until it has evaluated the branch, which means the vendor wants to confirm what are your choice or what's your order that you want. Hence, this will cause a branch delay for all the instructions behind, which means it will cause a delay of ordering food for the rest of the people behind you. Is that understood and clear for you guys?
Yes.
Okay, so in a nutshell, instruction pipelining allows overlapping execution of multiple instructions with the same circuitry and thus faster CPU throughput that would otherwise be possible at a given clock rate. So that's it for class today, and thank you for joining me, class. So class dismissed. Thank you.
Thank you.